So we're going to look at a couple of other examples where we find the area under the standard normal distribution curve. So our first example asks us to find the area under the standard normal distribution curve to the right of z is equal to 1.60. So just like all the other problems that we have worked, we're going to start by drawing a picture of our curve. We're going to draw a line down the middle, which will be our mean, and remember that your mean is always 0. Next, we're going to draw a line for 1.60. Since 1.60 is positive, we're going to draw that line on the right-hand side. Now, the problem asks us to find the area to the right of 1.60. And so we're going to shade the part of the curve that lies to the right of that line. When we shade like that, we shade in what is called the tail of the curve. So once that's done, we're then going to go to our table and we're going to look up 1.60. So remember, we find the 1.6 down the left-hand side and the 0, the hundredth place digit, across the top. And we intersect that row and that column. And so it looks like we are at 0.4452. Now remember that whenever we use the table to look up a z-score, the table gives us the area between 0 and the number that we looked up. So if I looked up 1.60, the 4452 is the area from 0 to 1.60. So this part is 0.4452. And what I usually tell students is that when I mark that off on my curve and note to myself that it is not shaded, I can use that as a hint to help me remember what to do. Since 0.4452 is not shaded, it is not part of the answer that I want. And so anytime you have something that is not shaded and you can say to yourself, I don't want this, then that is a clue that that is going to have to be subtracted off of something. So I know that when I get to the point of doing my final calculation, it's going to have a minus 0.4452 in it. So again, anytime you have a curve where you have noted an area and that area is not shaded, that is a clue to you that it should be subtracted off. Now, the next question is, what do we subtract it off from? I don't have another number to look up in the table. And so what I'm going to have to do is to consider the fact that if the entire right-hand side was shaded, okay, so I'm going to draw another little second curve over here just to illustrate my point. So if we had a problem where the entire right-hand side was shaded, what would the area of that shaded part be? We talked about this in the last presentation. We talked about how the entire area of the curve had an area of 1, and if I shaded an entire either left side or right side, that left side or right side had an area of 0.5. Okay, so what I'm going to do is I'm going to come back and say to myself, the entire right-hand side of the curve would be 0.5. I don't want the 4452, so I'm going to take that off from the total, and that should leave me with that shaded region. So the question was, what are we going to subtract it from? We're going to subtract it from 0.5. All right? So think about that, whether that makes sense or not. 0.5 is the entire right-hand side. The 0.4452 is the part that we don't want, so we're going to take that off. And what we're left with should be the area of the shaded region. So this is going to be 0.548. That will be our answer. And that will be that area of that shaded region. Now our next problem is fairly similar. We're just going to do it on the left-hand side of the curve. So it'll give us one more chance to talk through it. So we want to find the area under the standard normal distribution curve to the left of z is equal to negative 1.34. So again, I'm going to start by drawing a picture of my curve. I'm going to mark off the negative 1.34 because it's a negative number. It's going to be on the left. And the problem tells us that we're going to shade to the left of negative 1.34. So we're going to be shading in what we will refer to as the left tail of the curve. So now I'm going to go to my table and I'm going to look up 1.34. So 1.3 down the left and a 4 in the hundredths place. And again, we're going to go over and we're going to come down and we're going to intersect right there to get our answer. All right, so 1.34 is going to be 0.4099. And remember, when you use the table to look something up, you are getting the area from 0 to the number that you looked up. So from here to here is going to be that 4099 number. And again, if you'll write it that way, where you've written it inside the curve, in the correct part of the curve, then you will notice that you have it on a part of the curve that is not shaded. And if the 4099 is a part of the curve that is not shaded, it's going to need to be subtracted off. Okay, so that's our hint. Not shaded needs to be subtracted off. All right, subtracted off from what? I don't have another number to look up in the curve, and so the only thing I can use is the entire left-hand side. So I'm going to take the entire left-hand side of the curve. Okay, which we know the entire left-hand side of the curve is 0.5. So I'm going to take that entire left-hand side of the curve. I'm going to take off the part that I don't want, which is the 4099. And that should leave me the area of the shaded region. So when I subtract those two, I get 0901. Which is the area of that shaded region. Okay, so our last example, we're finding the area under the standard normal distribution curve between z is equal to 0.34 and z is equal to 1.53. So note that in this problem, they have given us two z-scores that are on the same side of the curve. Okay, so I begin with a picture of my curve, and I'm going to mark off both of those z-scores. Both of the z-scores are positive, so they need to be both marked off on the right-hand side of the curve. They need to be in the correct order, meaning the one that's closest to 0 needs to be the smallest of the two values. So even on a number line, 0.34 would come in first, and then further down the line we would have 1.53. So I'm going to draw a line here. We're going to call this 0.34, making it fairly close to 0. And then further down the number line, I'm going to draw a second line, and we'll label it 1.53. And the problem says that we want to shade in between those two numbers. So we're talking about this section right here. Okay, so let's go to our table. By now, you should be fairly good at looking these values up. So let's look up 0.34 on our table. 0.34 on your table gives you what area? All right, so you should be at 0.1331. And you should remember that that is the area between 0 and the 0.34. So that is right here. Okay, so now let's look up 1.53. When you look up 1.53, you should be at 0.4370. And again, that is the area from 0 to 1.53. So that section right there, 4370. Now, what do we need to do with these two numbers in order to get our answer? Well, we said in the last couple of slides that if we have a number that is referenced to a part of the curve that is not shaded, that we would subtract that. So I know that this 1331 should be subtracted off of something because it is not shaded. So what would we need to subtract it from? Keeping in mind that the 4370 has to have something to do with it. So I think it makes sense to come in and subtract that 4370 minus the 1331. Keeping in mind the 4370 is the sum of the two areas. So we're going to take the total, take off the one that we don't want, and that should leave us the area of the shaded part. So doing that subtraction gives me 0.3039. And that would be our answer. That would be the area of the shaded region. Okay, so again, I want you to work a few of these problems and make sure that you agree with the answers as they're given on the slides. So you have 3 problems. Try these by drawing a curve, shading the appropriate area, looking up your area in the table, and then deciding how you want to manipulate those answers to get your final answer for your shaded region. If you have questions or you need help, please send me an email and ask those questions.